Let us solve one problem from GATE physics. So the problem states that consider the op-amp circuit shown in the figure. If F1 is given as V1 sin omega t and V0 is given as V2 sin omega t plus phi, then the minimum and the maximum value of phi in radians are respectively. So we can write the V0 and Vi and V out are given. So Vi it is given as V1 sin of omega t and V0 is given as V2 sin of omega t plus phi. Right, we are to determine the minimum and the maximum value of the phase phi introduced by the circuit. We will recognize the circuit. The circuit is an inverting op amp with an frequency dependent feedback. The input resistor is R, feedback resistance ZF is RF parallel to 1 by j omega c. Right, because it consists of both resistance and the capacitance. So we want to analyze the feedback impedance. So Z feedback equal to, we can write 1 by 1 plus RF plus j omega c. So we will get RF plus 1 plus j omega c RF, right. So we can have the transfer function. So the transfer for the inverting op amp gain is given as the inverting op amp gain, we can write that A equal to j omega equal to minus ZF by R, right. So if we write, it will RF we have already found in the above step into R into 1 plus j omega c RF, right. So let us write in the polar form the magnitude. We have the magnitude of A, we can given as RF by R root over 1 plus omega c RF whole square. So we have a phase we can write that 5 phi equal to argument of minus 1 plus argument of 1 plus j omega c RF. So we will have phase equal to minus phi plus tan inverse minus omega c RF by 1. So it will be phi equal to minus pi minus tan inverse omega c RF, right. So but the phase of the transfer function is defined by the modulo 2 pi. So we shift pi minus pi minus tan inverse omega c tan inverse omega c RF by plus 2 pi if needed, right. So phi will be then tan inverse omega c RF, or implies it is implies with between minus pi by 2 to 0. So it will implies between minus pi by 2 and 0. So the final answer of our problem is minus pi by 2 and 0. So according to our option, the option D contains this answer. So hope this problem as well as the solution is clear. So thank you.